Yeah, probably -1. Just make sure you put a sub n when you do the recursive or the explicit, either one. Make sure you do
It's
that.
a formula.
So, yeah, because it's a formula, right. Okay, number 4 is 3, 6, 12, 24, 48.
I wonder what's going on here.
All right. What is going to take us from 3 to 6, 6 to 12, 12 to 24?
Times 2.
That's going to be times 2. Okay, so just keep doubling it. Okay. A little side note here, arithmetic or geometry? Definitely geometric. Convergent or divergent? If you keep doubling, it's going to get really big, isn't it? Okay. Now there are 2 ways we've learned to get to divergence, actually. And there's a third way, but we don't have that on the test. But to get to divergence, is it divergent because it's linear and it just keeps climbing steadily to infinity?
Yes.
Or is it divergent because it's exponential? It skyrockets to infinity. Which one is it? If you're multiplying, it's exponential. Okay? Let's put some rice on a chessboard. And let's keep doubling the grains of rice. It's going to be insane. All right? If you're doubling, tripling, multiplying, that's exponential. If you're just like adding to, adding to, adding to, that's kind of like the slope. Up to, up to, up to, up to, that's linear. So if you see addition or subtraction, that's linear. But if you see multiplication, division, that's exponential. Okay? So it's going to go way up there and be divergent, of course. All right? Remember that for later? Okay. Now, let's see. I need to find the nth term. Okay. So the first term is 3. The second term is 6. Third term is 12. Fourth term is 24. And the fifth term is 48. And now I need to wave my magic wand over this board and try to make 1 turn into 3, 5 turn into 48, abracadabra. All right, how do you do that? Well, notice the common factor. Always helps to pull out a common factor when you do these problems. Okay? They're all 3s, so that's 3 times 1, 3 times 2. A little bit of a pattern there. 3 times. I thought it was going to be 1, 2, 3. No, that's okay. 3 times. Oh, wait a minute. 3 times. Oh, that's another type of pattern.
Wow.
Hey, two sets of numbers you should recognize. The perfect squares, which we just did on number 3, and you know what these are called? These are all called powers of 2. Because it is 2 to the 4th, 2 to the 3rd, 2 to the 2nd. Okay, that's the chessboard right there, right? Just keep stacking up the grains of rice. So powers of 2. So that's a pattern. If you see that, just know, oh, okay, that's that pattern. It's 32, 64, 128, just keeps going, right? So, all right, the nth term would be, what is consistent right here? What's constant? 3. Now let's think about this. The 5th term was 2 to the 4th. The 4th term was 2 to the 3rd. 3rd term was 2 to the 2nd. So it's 2 to the minus 1, and that works. Okay? As we said, multiplication is not linear, it's exponential. Isn't that an exponential right there? See that? That's like 2 times, or 2 to the x minus 1, or something like that. Okay? Definitely exponential. Okay? And you actually don't have to put the a sub n, that's okay. If you want to put it, you can put it. Okay? Since it's not a formula, it's just kind of like what's the nth term, so it's up to you. All right? So you got that. Good for you. All right, now, next one. Number 5 is 3, 5, 7, 9, 11. Okay? That is most definitely arithmetic. No doubt about that. Convergent or divergent? It's divergent. It's going plus 2, plus 2, plus 2, so you're adding 2 each time. It's going up. But it's going up in a what fashion? Linear fashion, right? Again, it's like slope. Rise 2, rise 2, rise 2. Okay? So that's linear, but it will keep going up to infinity. So it's most definitely divergent. And it is definitely arithmetic, as we said. All right? So, let's see if we can figure out what the pattern is to do the nth term. All right, so 1 goes to 3, 2 goes to 5, 3 goes to 7. Okay. How do we wave our magic wand and get 5 to turn into an 11? They can double it and add 1. Okay? Did you know there are actually infinite ways to change a 5 into an 11? There are.
2n plus 1.
Yes, but my whole point is, make sure it works for multiple steps, not just one step. You could say, okay, how about we multiply by 10, 50, and then take away 39. That works, okay? But the whole theme here, make sure it works on everything. We've done some in class, actually, that looked like it could have been one way and turned it to be the other way, and we didn't quite know. So if you double and add 1, that works. Double this and add 1, check another one, in other words. So I'll just check one of them. If you double that and add 1, does that work? Okay, double that, add 1. Okay, that's good enough. Check about 3 or 4 of them, that's good. All right, so when you get to the nth term, how do you double in and add 1? 2n plus 1, sure. Okay, and that's your nth term. And you know what? This first part of the test, it's 1 through 13. These are pretty fast-moving problems, so you'll get done in like 15 to 20 minutes. You'll have lots of time to check your answers. Take the time to test your formula, and then just plug in a 5, make sure it gives you 11. Or how about this? Plug in 6. If you plug in 6, what do we get here? 13. Well, that would be the next one. Just make sure. Because if you plug in a test point and it's working, then you've got the right sequence. Okay? So you can actually check all your answers on the front page. It's like Mr. Wade dropped a key next to your desk. Oops. Okay? There it is. All the right answers. Not the false key that I once dropped, but that's a different story. Okay? The fake key, I'll talk about that sometime. But anyways, but it's like the real key is laying right next to your desk. You can make your own key and just go back and try every one of these, and if it works, you got the right answer. If it doesn't work, you're wrong. Go back and change it. All right? Yeah, we'll talk about that one later. It's a long story. Okay. Anyways,
You should share.
we'll share off camera. Okay. Now, 40, 20, 10. Okay. Let's see. How do I get from 40 to 20, 20 to 10, 10 divided by 2? It's got to be divided by 2. Okay, so we're just cutting it in half. Otherwise known as multiplying by 1/2. So that means this one is a geometric, and it is also, it is most definitely convergent. Right? Okay. The only way you're going to get convergence. Notice a lot of these are divergent. The only way to get convergence is if you are dividing, and also it has to be a number that is greater than 1. Okay? If you're dividing by 1/10, you're actually multiplying by 10, that wouldn't do it. But if you're dividing by a number that's greater than 1 whole, you are definitely in convergence. That's the only way to do it. Okay? So if you see division, that's probably the convergent. So, let's see what we have here. 1 has to change into 40. 2 has to change into 20, 3 into 10. Abracadabra. Alright, how in the world do I get those n's to change into those a sub n's? That's like your n, that's your a sub n. Okay? Well, remember, if it's a decreasing sequence, they're a little trickier when they're decreasing, since this one's going down. But if it's decreasing, here's what I would do. I would base everything off of the original term right here. Okay? So, here's a scoop. 40 is actually just 40 times 1. Okay? It's just itself. All right? How do you get from 40 to 20? We multiply by 1/2 to get to the next step, all right? So the next step is 40 times 1/2. All right? Any idea how to multiply 40 to get 10? And that's a wrap for scene 1.